Good morning, everybody. My name is Yang Liu. I'm a faculty member at Emory University Raleigh School of Public Health, and it's my pleasure to moderate this session. You're in session 2B, improving wildfire smoke forecasts and hindcasts. We have 4 speakers in this session. Each of the speakers will talk for about 10-12 minutes. And then we'll have about half an hour for a group discussion. How does that sound?
That sounds
Cool.
good.
I hope I have all the speakers in the room. I just talked to Alberto, Katie. There we go. Jeff. There we go. And Jessie. Okay. Alberto, podium's yours. You're gonna have to use the mic.
Okay, that's fine.
No problem. All right.
One more thing. For the burning 1 or 2 questions, you may ask them right after Alberto's presentation, and then we'll leave all the discussions in the end.
Well, thank you. And thanks everybody for attending this session. It's great to be here and share some reflections. Again, I'm Alberto Ayala, the head of the Sacramento Metro Air Quality Management District. For those of you that don't know, and I'm glad to see that we have a few policymakers in session. So the way implementation of the Clean Air Act happens in the US is you've got 3 levels of government. You've got obviously EPA at the federal level, you've got states, and then you have a bunch of regional agencies like the agency I lead. So we each take a piece of the Clean Air Act. So I'm definitely coming at this from the policy maker perspective. And I'm also glad that we had that wonderful introductory session this morning, because I think a lot of my reflections are going to be very consistent with some of the things that we discussed this morning. And so here we go. So obviously, we've already proven, as we have heard, and this is just one example of a very California-centric study that was done a few years ago, led by Emory University. Where satellite observations were used to do trend analysis and accountability. And what that really means is accountability of, are the policies to reduce air pollution actually working? You can use observations, ground-based, and obviously satellite now to do that accountability analysis. I just have an example here. This particular study in Southern California was looking at PM through nitrate sulfate, EC and OC. So you can see that the changes in the colors indicate progress. And that's great to see, because again, you're seeing the application, the direct application of the observations for something that is very relevant from a policy standpoint, right? Are the regulations, the rules, the policies working? And the question I pose for this group and for HAQAST is, we need to continue to do that in a more focused way, if you will, especially when it comes to assessing the impacts of wildfires, which, depending on the event, us in Northern California, we have been the epicenter of, unfortunately, some of the worst wildfires that we have seen in history. So this is an area of high interest to us. And again, here is another graphic on my right, so your right as well. That's the use of satellite observations to look at the behavior of the wildfire impacts. So we definitely, the regions, the states, support the application of the very practical use of the satellite observations just to understand behavior. And then on the other graph is really why. Because for those of us with responsibility to meet the National Ambient Air Quality Standards, the 2 graphs shows you the impact of wildfires. So these are ambient PM 2.5 values in the Northern California region. The 2 lines show you the impact of wildfires. And if we take out the days that our ambient air was impacted, so with and without wildfires. And really the message here is, it's make it or break it for us. If there isn't a way for us to go through the exceptional event analysis and tease out the impact of wildfires, which obviously we have no control over, you can see that that can mean meeting or not meeting the ambient air quality standards. And that has huge implications for public health, obviously, but even more important, particularly for politicians, transportation funding that comes out of the federal government, you know, the huge monies that every state and region get from the federal government is depending on us meeting the air quality standards. So I would say that one of the most important jobs that people like me have is making sure that we ensure conformity in transportation with the air quality standards. And again, there is an opportunity, we all understand this, there is a growing list of sensor technology, portable sensors, low-cost sensors, that people are just on their own going online and buying. And then they show up on the AirNow webpage, right? So they have become really useful tools that people are getting really accustomed to. And I think it behooves all of us here to try to understand what is the right pairing of that information with some of the satellite observations that we're discussing today. Another topic where, again, it was touched on this morning, our federal government is currently undertaking an assessment of the National Ambient Air Quality Standards for PM 2.5. Rightfully so, because the science is telling us that we need lower and lower limits of that pollutant in ambient air to protect public health. But it's really gonna pinch a lot of regions because, you know, as I show you, the levels are yes, the levels are already pretty, sorry, I had a question. The levels are already pretty low, and now we're gonna lower them some more. So the question is, you know, can we use, as I asked this morning, can we use satellite information to try to understand where we really land with respect to ambient PM? Because for many of us, the standards that EPA is considering potentially as low as 8 micrograms per cubic meter on an annual basis, you're really getting close to background. So I think we really need to have a serious discussion about, I mean, if your background is already there, what else are you gonna do to make the commitments under the Clean Air Act? Another area that, you know, potentially could be useful for us, obviously the lockdown under the pandemic is something that benefited us from an air quality standpoint. We did an analysis and we determined a significant improvement in air quality, and we associate that with a huge reduction in driving. We saw a 74% reduction in vehicles miles traveled during the deepest part of the lockdown. And we quantified, as you would have expected, air quality benefits. You know, can we do that using satellites, right? Not to say that we're gonna go into a lockdown, but I think the evidence to tie transportation emissions as the biggest source of air and climate pollution and the improvements is something that certainly communities want. And then the last thing, obviously, we talked about it, exceptional events, right? The graphs you have here is from Office of the Inspector General study that you can see that over time, there's a number of increasing proposals or applications for exceptional events. And again, that's tied because we're seeing more and more wildfires. And that's gonna be a key area for satellite observations. And then EJ, right? I think there's a huge gap, but also an opportunity for those of you that are working both as HAQAST members as well as the Tiger teams, because we need to work together to make sure that communities understand the potential power of using satellite data. You know, many of us are doing like all kinds of different things. We're deploying sensors at the local level. We're doing street mapping, right? Driving around in the Google cars of air quality monitoring to try to generate the information that our communities want, that is highly localized. And I think at this moment, communities, I don't think are even aware of the power potentially coming from satellite observations. And then the last thing I'll say to wrap up is, you know, something that gets back to the way Tracy answered my question. There's so many different options out there that one can use to look at health-based air quality information, right? And it's all great information, right? The goal of standards since the beginning of the Clean Air Act has been the regulatory networks. We're still running them today, we're still doing the same thing that we have been doing from the beginning of the Clean Air Act. So the gold standard is evolving as well. And I think we do need to ask ourselves, one, how do we use this growing list of options to monitor air quality, including satellites, right? And what is the right approach so that we can be more efficient, more effective, and more impactful using this data to really do what we're all here for, which is to protect public health. So I think that's my last slide. Thank you for your attention.
One quick question before we move on. You know, I got so many questions, but let's keep it to the end. Our next presenter, Katie.
All right. Okay. So hi, everyone. My name is Katie Broyles, and I'm an air quality meteorologist with the Colorado Air Pollution Control Division, which is a part of the Colorado Department of Public Health and Environment. So it's great to be here with you all today in St. Louis. This is my hometown, so I'm super excited to be home-ish, even though home is Denver, Colorado now. Today, I'm going to talk to you about a couple of the ways that the meteorology team at the Air Pollution Control Division uses satellite data to pinpoint our health messaging and our forecasting to get the right message to the right folks during wildfire events. And this picture is actually from the Cameron Peak fire. This is from August of 2020. That was a large fire. A couple of years ago, 2020 was kind of a busy wildfire season. So I'll get into that a little bit more, but that's what it looked like. We have a lot of fire in Colorado. So as I mentioned, I work for the Air Pollution Control Division with two other meteorologists, Dan Welsh and Scott Landis. And as a team, we issue an air quality forecast every single day, so 365 days a year. And we issue a health message with any time any pollutant is expected to be above the good category. And in addition, we also issue air quality health advisories as needed. So during periods of wildfire smoke and other events that cause kind of out of the ordinary circumstances, we issue an air quality health advisory. So this is what those forecasts look like on our website. Circled in orange is the ozone forecast, and I just show that to show you how we include the health message and the time frame. So that was a day we were expecting moderate ozone, but good everything else. At the bottom, circled in blue, is our smoke outlook. So this was on a day when we didn't have any fire activity and we weren't expecting any fire activity, but this is what we keep up all the time in the event of a small wildfire or any prescribed fire, because we don't cover prescribed fire in our health advisories. So we just keep this information up there at all times. So any folks that are near a prescribed fire or a smaller fire can protect their health. Now, this is our smoke outlook when we did have some fire activity last week. There was a small fire burning in southern Colorado. So there's some specific information that pertains to that particular fire, circled in blue. And then below that, still the general health message, because fire is possible all year. And we want to make sure that we have that messaging up for folks if they're near any smoke. So as operational meteorologists, we use really any tools that we can find to help make our forecast as accurate as possible. So we're looking at surface observations, we're looking at radar, models, use purple air data, we monitor social media, we look at webcams if that's available and helpful for us. And of course, we also use satellite. So today I'm going to kind of go over a couple of ways that we use satellites and where that fits in our forecasts. And three of those ways are, number one, to fill in the gaps in our monitoring network. Number two, to monitor smoke production and transport. And number three, to check for new fire starts and to gauge fire intensity. So I'll start with monitoring gaps. This is a map of our state-run real-time air quality monitoring network. And circled in blue are the areas that have a PM 2.5 monitor. So we'll ignore the one down in Cortez in southwestern Colorado and the one in Pueblo. Those are just ozone monitors. So we do have quite a few monitors across the state. Most of them are clustered in major population centers, primarily the Front Range. That's where Denver and Boulder and Fort Collins are. So there are large areas of the state that lack a regulatory monitor. So one of the tools that we use to help fill in those gaps is purple air data. We have a lot of adoption across the state, although some places, rural areas, will only have maybe one purple air monitor. And there are also issues with purple air data because it's not quite as reliable as regulatory data. There's some instrument error, human error. So we mainly use purple air data as kind of a temp check to see what might be going on at the surface and areas that we maybe want to investigate a little bit further. But it is a helpful tool, gives us some more fine detailed data compared to our regulatory monitoring network. So visible satellite imagery can help us during a smoke event determine areas that might need to, areas where we might need to issue a health advisory and some health messaging. So this is actually an image from August 21st of 2020. This was during the Cameron Peak fire that I showed at the beginning. So comparing the areas where you can see smoke on the map to where we have regulatory monitoring coverage, you can see there's a lot that is missing in terms of ground-based observations. So on this day, there were actually 2 health advisories that went out that included several counties that had either no monitoring data at all or had maybe 1 purple air monitor. So using the visible imagery, it really helps us to be able to see things that we can't see, quote unquote, otherwise in the ground data. Now, zooming out to the entire Western US, this is also from the same day. So August 21st of 2020, it was a really heavy wildfire season that year. And you can see there was a lot of smoke in California that was making its way into Colorado. There were a lot of fires across the Western US. So using visible satellite imagery, we could also see where smoke was coming from, see how thick it was at the source. And that helps also with forecasting and just to see where it's coming from. That is helpful as well. So moving on to the third way that we use, the third type of satellite imagery we use in our wildfire forecasts. This is the Band 7 or shortwave window product. And circled in red is a very, very small grass fire. It's kind of hard to see, which is why I circled it, but it's right on the border of Teller County and El Paso County. So this is actually from last week, I believe. And there was a red flag warning in place. We were watching for new fire starts. And we saw on the Pueblo interagency dispatch that there was a small grass fire that had popped up. It was estimated to be less than 10 acres. So what we did was we decided on a watch and wait approach before we issued a health advisory. So there were a couple of pre-evacuation notices in place for nearby residents. But since we didn't see a high potential for spread, we decided to wait before issuing, and it ended up that the fire was put out before we could have even gotten a health advisory out. This is important because we try to be really judicious about when we issue health advisories because we don't want to just issue them constantly and have them be kind of obsolete by the time the message actually gets to people. And also, if there was hardly any smoke coming from it at all, it doesn't really seem like, if you're a member of the public and you're seeing almost no smoke, it's like, what are they doing? So we try to be careful about when we issue them so they don't just fade into the background and people don't see, oh, it's another health advisory, I'm not going to pay attention to this. So using this product really helped us to target that message and kind of decide to hold off and make our message more strong when we do have to issue it. And just to compare that tiny, tiny, tiny white dot with some actual fires, this is the same product from a different day. When the Cameron Peak fire was burning, you can see how prominent those are. So it really kind of illustrates how small that fire was that popped up last week. So we're glad that we didn't have to issue a health advisory. So satellite's a super powerful tool for us, although there are some challenges Obviously, using visible satellite imagery, it's a struggle when there's cloud cover. It's hard to parse out where the smoke is. And also overnight, smoke isn't visible. So that's kind of tricky for us. And also in Colorado specific, or really any mountain state, it's difficult to detect smoke in complex terrain. But even with all these challenges, it's a really, really instrumental tool. We use it for a lot of things, not just wildfire, but forecasting would be a lot harder without it. So just to recap all of that, at the Air Pollution Control Division, we issue a daily health-focused forecast. We issue air quality health advisories, so those show up as air quality alerts on the National Weather Service page. We issue those as needed, and we use satellite data to help fill in our monitoring gaps and monitor smoke production and transport, and to look for new fire starts. And that's all I have for you all. If you have any questions.
I got a quick question, Katie. So can you confirm that satellite data is not entering any of the quantitative analyses line of work?
Yes, we don't use it for quantitative, just we're making our best guess with our meteorological know-how to kind of determine how much smoke we might think reached the surface and determine a health category on that. It's not an exact science.
Thank you.
So the air quality dailies, is that for the entire state? Oh, sorry. Is that for the whole state, the air quality daily notices?
That's a great question. So yes and no. We do have one that's specifically focused on the Front Range because we have an ozone non-attainment area there. But we do monitor for smoke throughout the state. The thing is, really, other areas in the state don't necessarily have the same air pollution problems as the Denver, Boulder, Fort Collins area. But we are watching for smoke, and we issue for both. But that one that I showed was just Front Range specific. Does that make sense?
Mhm.
Okay.
Thanks, Katie. Jeff, you ready?
Hi, I'm Jeff. I'm a professor of atmospheric science at Colorado State University, so staying in Colorado. And the work here that I'm going to show is lots and lots of contributors. I'm going to highlight a few down the road, but it certainly is not exhaustive. So this is just going to be sort of a history of what collaborators and I have tried to do to develop our best estimates of like who breathed what smoke when. And this is mostly from a Hindcast, meaning smoke that already happened rather than forecasting or real time. So quantifying exposure to wildfire smoke is really hard. You have these like really big changes in whether the smoke's at the surface. So you can be looking at smoke from satellites from space and clearly see your eyes tell you there's smoke there, but it doesn't necessarily tell you if people are breathing it or not, because a lot of times, this is again the Cameron Peak fire that Katie just showed. This is a grad student of mine was driving between Laramie and Fort Collins, and he was under the smoke, but was not breathing any of it. That's challenging, as well as you have these really defined sharp plume edges that can meander throughout the day. And so during Cameron Peak fire, I'd wake up and I kind of live near the river. So overnight it was channeling down the river, but then during the day it would kind of turn as the boundary layer spun up. So within a day, you can go from like super clean air to really polluted air. So you need to get often like times sub-daily coverage. And then I'm not going to talk about this today, but then in terms of health effects, the smoke chemically evolves. So we have all these imperfect tools that have strengths and weaknesses, and we try to figure out how can we exploit the strengths from each of these different things. So chemical transport models tell you everything you want to know, but they're not necessarily right. And so they still struggle with things, including injection height, the emissions, and so on. Satellites are great at telling you where the smoke is horizontally during the daytime, but they can't tell you unless it's a LiDAR or they have some sort of multi-angle thing, which doesn't have as good coverage. They can't tell you the surface impacts, and it's challenging still at night. And then we have surface monitors that are great, but they're not everywhere. Purple airs are certainly helping. But in terms of the regulatory monitors, they are very spread out. So what we really want is to be able to combine things to come up with continuous maps how much of what smoke there was in different places. So what we did, and we've played along with lots of different combinations, but the main product that we've used relies a lot on surface monitors. And so you can interpolate surface monitor concentrations and then use satellite imagery to figure out where smoke was in the column. Doesn't necessarily tell you whether the smoke's at the surface or not, but if we take what the expected concentration is at the surface and that for a given month and location, and you subtract that off, this allows you to get at what the smoke PM 2.5 was, just saying if it's typically 7 micrograms per meter cubed at a location without smoke, if the smoke was there and it was 20, then we subtract off 7, it's 13 is our best guess. This allows us to get time series of smoke and non-smoke concentrations for every location, and we do this daily. We don't do sub-daily yet, but there certainly is some need for that. And so this is just showing our product from this, or maybe I can't. There we go. This is 2020, and I'll go through, this is that same summer that Katie was just showing. We can get into that time. So California just spun up, and later fires are going to start. There we go. In Oregon, it goes wild. And so it's so we get this smoke specific PM 2.5 and non-smoke specific PM 2.5. So within our group, this allows us to look at things like trends. So this is what Alberto was just talking about that they do, where they try to subtract out the smoke influence. And so if you look just at summertime PM 2.5 from 2005 to 2020, or 2006 to 2020, you get in the East, all right, Clean Air Act is doing a great job, but in the West, there's this positive trend. And so what we could do with our product is you can subtract off the smoke influence, which is the positive, going most of the way across the country, and you get that the Clean Air Act's actually doing what it's supposed to do in the West. It's just that the smoke is interfering with it, exactly like Alberto showed for the Sacramento area. So then, where this gets fun is in the applications, though. So this is just with collaborators in epidemiology and economics. They can then use these products to then look at, like, as a function of how much smoke there is, how much do people are more likely people to get their asthma inhalers refilled, people to go to the hospital for asthma, and people go to the hospital for pneumonia. And what this is just a ratio of what it would be if there was no smoke to if there's 10 micrograms per meter smoke. And for each additional 10 micrograms per meter cube of smoke, it goes up. And so it's like 7% extra asthma hospitalization for every 10 micrograms per meter cubed of smoke, but then no difference they found in pneumonia. We've had collaborators apply this to effect on whether people have or women are having preterm birth, meaning their babies are being delivered early. And it correlates strongly with smoke exposure in the second trimester. So something is a hypothesis is happening during baby development or fetus development at that point. That shows that there's, for each microgram per meter cube of smoke, they are average over the second trimester, there's a 13% increase in the chance. And then working with economists, this is showing that for smoke PM 2.5, domestic violent crimes goes up as a function of smoke concentration. It doesn't correlate with anything like stolen cars or any of those things. So the suspicion here is that people are staying indoors or having asthma or allergic reactions where what might be a verbal dispute might be turning into a violent dispute. So the effects of smoke show up in lots of places. So then moving this product into HAQAST and what we're doing through Tiger teams and through a rapid response team, this is showing, this is the Tiger team that's led by Amber, who's in the room, and Cheryl Magzaman. So we've been looking at prescribed fire and smoke. So this is just one day. This is Eastern Kansas. So here's Emory, but this is the Flint Hills region. Every April, like 60% of the acreage burns in this region for prescribed burning. Very cultural. There's lots of reasons they do it, but it happens in this region here. And the regulatory monitors are in blue. The public purple air monitors are in orange. And there's exactly one purple air monitor in the heart of that region that existed. So what we did through our Tiger team was deployed more purple air monitors in the region and combine that with satellite information. Try to learn about what the concentrations are in that region during prescribed smoke season. So our student, Olivia Sablon, is looking at exactly what the smoke contribution is. And this, I'll show satellites on the next one. But this is purple air monitors on days where there's local burning. This is the purple air monitors from the same season when there's not, to try to show that on the burning days, more than half of the PM is coming from smoke. And it's, you know, it's not like in wildfires where you're at hundreds of micrograms per meter cubed, but the daily averages are going above 12 on those days. And the bright thing here for satellites is that here's two satellite products. This is Randall Martin's product that is monthly. We don't have 2022 yet, so this is a different year than the campaign. This is the recently released GOES daily product using the GOES satellite. And then here's our monitor showing the region. In both the satellite products during the burning time get this hotspot in the region. So in this case, satellites alone could probably get us a pretty good estimate. Okay. I'm almost done. And then this is an extension of that project. We're not as far into the analysis yet, but we're doing a similar thing for prescribed fires and agricultural burning in southern Florida. And this is just showing that in their burning season, this is the number of smoke days identified by satellite in this region and in their winter. Like within a 2-month span, more than half of the days have smoke identified in that region compared to the pre-burning season where there's less smoke in that region. And this is just a preliminary analysis. It's hard to get a lot out of it yet, but it's just showing that while the PM 2.5 concentrations in this region are always quite low, it does show an enhancement as we go into burning. But this hasn't been corrected for meteorology yet. So finally, the last slide here, this is just a project we're working on with the New Mexico Department of Health to get them information, particularly on the bad smoke season they had last year, and combining purple air monitors and satellites. And this is just a preliminary plot trying to identify where smoke was and what the contribution was. So Bonnie, so Chris Luatio is leading it, and Bonnie Ford is doing this analysis. And that's what I got. So thank you.
Thanks, Jeff. Alberto, quick question.
Just clarification, Jeff, great presentation. When you talk about the asthma and other impact increase with 10 micrograms per cubic meter, is that a daily or an annual average? Daily, okay.
Yeah, the end goal is harder. I'm not an epidemiologist, but the long-term effects of smoke is like the holy grail of epidemiology.
Thanks, Jeff. Wow, can't believe. Move on to the next speaker and last speaker, Jessie. Go ahead.
Hi, everybody. My name's Jessie, and today I'll be sharing some of our work to improve air quality forecast during boreal wildfire season, specifically over Alaska. So this is a HAQAST project led by Jing Moore at the University of Alaska Fairbanks. So I'm from University of Iowa, so we're collaborators. So I want to thank all the colleagues on this team and the stakeholders for their support and valuable feedback. So here, just a quick kind of the context why we develop a bias correction method to improve air quality method forecast. So we can see we're kind of in an area with a lot of global or regional operational forecast data products available from different agencies such as NASA, NOAA, and the Navy's different operational forecast products. As well, we have a lot of like satellite aerosol data available from the early models, and now it's Tempo being launched and Maya soon to be launched. So it can be overwhelming to think how to utilize all these data. So kind of to tackle this problem here, we are developing a multi-LD ensemble bias correction method to improve PM 2.5 air quality forecast. So this was done using like a model Hindcasts products. So we use a GeoScam, CMAC, and a WRF-Cam as the model ensemble members. And for the satellite LD products, we use both MODIS and WIRS data products. And this is done over the continental United States. I've seen the map. We use both the EPA AirNav hourly PM 2.5 measurements as well to improve observation data. So our goal here are really to seek synergy between surface observation networks and satellite observation by integrating all the data. And we're hoping to create a very computationally efficient way to improve air quality forecast products. So that's kind of our goal. So this has been done in the research mode to develop this method in a two-part study. So our first part only focusing on using model outputs and the surface observation to improve a surface PM 2.5 forecast for urban areas and suburban where ground observation are available. And then the second part, we just extend the study to integrate satellite observation to extend the bias correction to rural areas where ground observation are not available. So here, just a little bit of background information on our first step to improve the forecast bias at the surface observation using an ensemble common filter approach. The idea here is, for example, today at a local afternoon, when we get all the ground observation in the past 24 hours, from yesterday noon to today noon, and then we had the model raw forecast, and we can get the bias information for yesterday. Then we can use this common filter method to update this bias for next day, the midnight to midnight, which is based on the regulations. Then we can improve this by the bias information. Then we have the raw model forecast for the next day. Then we can crack this model forecast. If you have multiple model members, then we can do a simple mean to ensemble them. And then, so this is a quick, way to generate a single best forecast. It's not a data simulation. We're just using this common filter to a post-process bias correction. So it's very fast. And then, so that was done developing the research mode. Now we have extended this to make it operational over Alaska. So we just got it done recently. So every day we'll download for now, we download the global forecast data from NASA, GeoCF, GeoCFP, and the NAPS data too. And then we'll run this operational common filter at the University of Iowa using the purple air sensors in Alaska to correct the model bias. And then we'll send the data to Alaska. Then they have a website to display the data products. And then, for example, here's some quick preliminary results over July 2022 of fire time in Alaska last year. So here's the map, shows the model forecast products. On the left from GeoCF, on the right is from GeoCFP, and the circles are the purple air sensor observation. So we can see model kind of overestimate the observation. Then we apply this ensemble common filter method. So on the top row is the raw model daily PM 2.5 evaluated with the purple sensor measurements. And at the bottom one is a common filter correct results. We can see by using this common filter correction method, we can reduce the bias, and the ensemble can provide a better forecast. And then the next step, we're hoping to combine this AOD information to extend the bias. For example, these dots are the where places we have ground observation, and then we have the AOD data, and then we have the bias correction information. But for the square, where it's, for example, a rural area or far from the ground observation, then we only have the AOD information. We don't have the ground observation. Then we're hoping combine this AOD spatial pattern to extend this bias from the station to this place where no ground observation are available. And then, so we're hoping to use the WIRS data products in Alaska. And then we use this bias correction method through AOD to kind of find the ground truth in this place for today. Then we can use common filter again to update the bias and the forecast data for next day. So we can do a ensemble common filter again for the rural areas. And then this is done over the continental United States using the 3 models. This is, so the top one shows the raw model, and the bottom one shows the forecast, the bias corrected forecast products for next day. As we can see, it kind of promising using the satellite AOD to help correct this bias for next day. And yeah, that's our next step. So I think that's all I have. Want to thank NASA for the funding and thank you guys for listening. And I'm happy to take any questions. Thank you.
Thanks, Jessie.
Sure.
That was very interesting. I was wondering if you've looked at the bias corrected GOCF values. Their raw values aren't very accurate, but they've
Yeah.
done a lot of work recently to do some machine learning techniques to improve them at the local level.
Okay.
Have you looked at their
Data
yeah, their corrected data product before you do your Kalman filter?
I haven't yet. We just used this downloaded from their server, but definitely it's a good idea to compare with what they corrected.
Yeah, my impression, before they do the machine learning, I
Uh-huh.
think the data is not very, it's not usable yet for
Okay.
applied purposes. But
Okay.
once they, the machine learning step, it becomes useful for forecasting lots of things. So it'd be interesting to see if the Kalman filter could improve it even further.
Yeah, that definitely worth looking into. Thank you.
Right, thanks, Jessie. And let's give our speakers a round of applause for their excellent presentation. And in fact, everybody behaved. We have 30 minutes for our discussion. Nobody went over.
Is that what those chairs are for?
Not necessarily. Small room, we don't have to have you guys stand there. We're safe here. Let's just get started with questions. Actually, I have a bunch of questions, but Arlene first.
Sorry,
You also have a bunch of questions.
that's okay. I'll go on and see. So I think I'll start actually with a question for Katie. You mentioned very briefly in response to Young's question that you're using the AOD, smoke AOD or AOD qualitatively and combining with forecasts. And what my question is, are those purely meteorological forecasts or are you using any like air quality forecasts where you're actually seeing like PM 2.5 forecast and surface air? Or I guess can you walk us through how you do this? Thank you.
That's a good question. I mean, the way that I approach it is from kind of meteorological know-how and the shortest and smallest grid space model we can find. So we use a lot of her models. My colleagues may be aware of some other tools that they're using that that I don't use, but it's a lot of understanding the surface terrain complexity, understanding the forecast and understanding whatever data that we have at the surface. If there's, a purple air monitor that can help. But as far as I know, we're just using the tools we have as meteorologists and putting them together in the best way that we can to give a good forecast.
So we have a question from online, and I think this is specifically for Katie, but I believe everyone used some Go 16. So could you talk a little bit about the band selection for your work? So specifically the question is about using band number 1 versus number 7 for detecting smoke. So anyone, I guess, who used Go 16 could answer that, but I think it was for Katie.
Okay, well, I would offer that up to anyone else who also has information on that. As far as I know, band 7 just shows heat and intensity. I haven't used band 1. I'm not super familiar with that. And band 7 is just kind of something we keep up in the background when we're expecting potential fire. It's just one of the many ways that we can see new fire starts and monitor how hot they're getting.
Rebecca, to answer that same. Yeah, for smoke itself, I would use the visible bands. I don't remember the band numbers. But there was like in the far IR window, which is like the 9 to 11 micron range, and the bands are somewhere in the teens. is really useful sometimes for getting smoke height because fires that inject to the free troposphere often inject a lot of ash and big particles that will absorb far infrared and then re-emit at colder temperatures. So sometimes you can get a bit of information out of that if the smoke is away from the surface or not. So it's one of the ways you can maybe tease that out.
Thank you. This question is for Jeff. I really appreciated your talk, and the way you separated the map where you separated out the PM due to wildfire smoke. And I noticed a big hot spot at the bottom of New Mexico. And I'm wondering if you had any idea what was going on there in the absence of the smoke, when you take the smoke away.
Yeah, it's the one place where the positive trend doesn't disappear, right? Yeah, I suspect maybe it's fine dust, but we haven't investigated that. Others have asked. We probably should look into that more. Do you have insight?
Well, it's right on the border of Mexico. And I mean, I've been in El Paso and I've been in, Las Cruces, and there's no border for smoke. So I'm kind of wondering if it's an international problem.
It may be.
Cross-border.
The satellite data that we use to estimate if smoke may be in the column supposedly picks up on when smoke gets into the US from internationally, but it's possible that those are more likely to be missed. Daniel had his hand, yeah.
I just want to comment that we did see concurrent, happening that dust storms after a wildfire case. Yeah, and it's happening in New Mexico a lot.
Yeah,
Yeah.
okay, thank you.
Can I answer that question? Yeah, I have a question for Alberto. So you are looking for ways to use satellite data to deploy future monitors. I'm just curious, will that increase the burden for the state agency for non-attainment work? Is that a concern, or what is the priorities to select future monitors?
So thank you for the question. Actually, just to be clear, I want the satellite observation to put us out of business from running ground-based networks, right? So to your point, I'm very interested, and this is a request to the collective here. If satellite information does become better and better and better and more user-friendly, let's just be efficient and use that to do everything that we need to do under the Clean Air Act. So I think the point I was making again is you've got this explosion of technology, right? I mean, the sensors, the regulatory networks, the satellites, we've got the Yakima cars running around all over the place. You've got potentially drones and airplanes. So what are we going to do with all this information, right? Are we just going to keep running in parallel, or is there a way to sort of integrate and land on a better approach? And I think to your point is that's like the holy grail of policymaking and air monitoring. If we could actually have our satellites do all the very resource intensive work that is done on the ground to comply with the regulatory requirements. Hope that makes sense.
Hey, my question is also for Alberto. I'm Annie from Sonoma Technology. And you gave some really interesting statistics related to the COVID reduction.
Yeah.
There was a 75% reduction in traffic, and that turned out like a 10% reduction in ozone. So this was like a really interesting and unique experience for us all to do an experiment and see what would happen, right? But the number 10% reduction in ozone, was it enough to maintain compliance? And does this number give us any sort of constraint to what would be possible in almost a best case scenario of emissions reductions? And so kind of does that data of what we saw give us any sort of parameters for state planning of, if we're trying to get our ozone down or get our PM 2.5 down even,
Are there parameters on what's possible from what we saw from COVID?
Thank you for that question. And in full disclosure, STI is one of our principal partners in our work. So you are correct. We saw a significant reduction in the deepest part of the lockdown, April 2020, when again, a 74% reduction to be exact, in the 6-county region in Northern California. And we associated that with the improvement in air quality. The point I made about the national ambient air quality standards getting so low that you are hitting background comes from that study, because you're right, we saw a reduction in ozone particles and other pollutants, but it didn't go to zero, right? So there's no way under current circumstances, any urban area in the US or the world is going to see a 75% reduction in driving, right? So I think the point is well taken. We are trying to understand the limits of what we can do with ground-based monitors. And in fact, one of our projects with you guys right now is we're doing a street mapping. We've been driving around with you guys around the area to try to understand localized effects. But I think this takes me back to my point on the satellites, right? Might that be, perhaps eventually, maybe not today, but might that be a better way for us to tackle the questions that we're posing with the regulatory networks?
Questions? Whoa,
I have a question.
you just answered a question.
Yeah, but now I have a question.
You have it.
All right. So I wanted to more specifically, Jeff, ask you, when you compare with and without wildfires, are you just looking at the same time reference? So say a year ago, same week without a wildfire, or are you looking at other parameters to make that connection?
This isn't an epidemiology study or economic study. Choosing the reference period is definitely one of the key things, and you need to then move that window around and see if it changes your results and those sorts of things. Usually you try to get a time period just before, but you need to be careful. It's like, well, pollen was out during that time just before the wildfires. And so you need to, then it was flu season and there's all these kinds of things. And so the epidemiologists have that down. It's certainly in a combination of art and science. I don't know if you want to comment on that, Yang. Like, you probably have to think about. Yeah, but you work with them a lot too. So yeah.
Can I do a quick follow-up? So another plug for STI, because actually the air quality improvement data that we collected was working with you guys as well. So we haven't published this work yet, but the way we are determining the like for like period is not just looking at the time, but also other parameters like the boundary layer height and the wind conditions. And because the biggest unknown is the inventory of pollution changes, right? So you don't know if you compare today to 2 years or 3 years from now when there's a wildfire, you don't know how the inventory changed. So we're trying to understand, working with STI, what additional parameters we can impose other than timing to ascertain that you are looking at like for like period. So then you can say yes or no.
So it seems like yours is more in terms of figuring out smoke versus non-smoke. Yeah, so in that part, okay, so I missed that. So there's the reference period for epi, but when we're doing this non-smoke subtraction, we are taking the average of all non-smoke days from a 3-month period around that month, not doing those, which is the next step and would be better. I agree. Yeah. Daniel, you had a question, right?
Yeah. So this is a question for Jessie, and maybe also for Keith and Amber here too. So when satellite data are used for wildfire forecast, do you think it will be more useful for large, longer, large fires or compared to prescribed burning or agricultural burning. Those are the short-lived fires, right? If you use AOD, for example, into the model and trying to force the model to use the historic data set, will that increase your performance, increase accuracy of your forecast, or the other way around?
That's a very good question. Yeah, we're just starting to look at the how AOD could help. So I did it backwards in the continental United States over the whole United States. So I think the fire was there some big fire for what we did. It helped, but I think that's a good question with the, like you talk about the prescribed fire versus a large fire, right? I think it just depends on, I guess, also how sensitive the satellite, the AOD products are. So that's a good question. We haven't really further explored much, but I think that's definitely worth it to compare the continental United States versus look at Alaska. So kind of look at different fire events and to see how this method could help, I think. Yeah, that's just kind of something I just thought about. I don't know if other people have other thoughts.
Okay, question or an answer? Question.
So one of the things that's hung us up a bit with smoke and satellites is that fires and then the smoked associated smoke tends to do very different things at night. When the fires smolder, particularly if it's in mountainous regions, it tends to channel down valleys. And I could see it in the image you showed during the Cameron Peak fire period, where most of the smoke was from California. But if you look down the Poudre River Valley and the Laramie River Valley, was that from the morning, that satellite image?
I think so.
Because usually by the afternoon, you wouldn't see the smoke pooling in there. So I've been curious, and we haven't done this yet, but I've been wanting to know if people have been starting to use geostationary satellite images from right when the sun rises. You can really, I mean, like qualitatively, you see it just sort of pooling in the valleys and stuff. And I've been curious to know if people either on the regulatory forecast, like in forecast side or in the research side, have started using that sort of first daily images from geostationary to get that nighttime smoke effect. Okay, I guess I'm not the only one who hasn't done it yet. So
I had some very limited experience dealing with early morning present with ghost imagery. The data missing is enormous. The bad angle, and also from the low light.
you mean in terms of an AOD perspective, it's missing? Yeah.
Yeah, there's just too much missing.
Right.
Doesn't provide a whole lot of information. And also the problem with Go 16, 17, and 18 is the resolution is still not sufficient, right? At the oblique angle, you're looking at a pixel size of 4 by 5 at best. You know, we're talking about a narrow valley. Not very, I haven't found it very informative for early morning satellite.
Just want to check, is that on?
It is, I think it's on. Is that on?
It's hard hearing you. On it off.
Hello?
Maybe it's off close.
You have a question?
I just wanted to add a little to some knowledge that I have to call it the conversation. So what you were talking about, Brad Paris is in the other room and he's working with Mike Pavlonis right now to update the GOES 5-minute data so that there's better clarity for both reasons, for the size of the pixel and the topography, but also the angle, the viewing angle of the satellites for looking east and west. So we should expect to see a better geographically located product. Still, it's going to be a larger 2x2 meter pixel, which is better than we've ever seen before with 5-minute data. So we keep getting these great data and then we want more, which is normal and right. Pardon me?
We're a pretty bunch.
Yeah, exactly.
But the nighttime as the boundary layer falls, and especially in valleys, that's a big issue. And the only way I can think to get at that right now is a monitor, and also making sure that is in the models, that effect, which is challenging, but it really needs to be there because that's some really bad air quality in the valleys. So that's important for health, for everything.
Well, I just forgot that one.
So I have a question for everyone. So all of your talks mentioned or directly talked about the sort of sporadic distribution of monitors and adding monitors in some cases. So I'm sort of wondering what you see sort of the future of low-cost sensors like Purple Air for things like forecasting of wildfire smoke, and how we can use that to better integrate into meteorology and ensemble modeling and stuff.
And I just want to add on top of that, Purple Air has started charging subscription. Just think about that.
I'll get it started. So two things. Clearly, we're going to see more and more use of this, right? I mean, somebody who's been working in the policy space for a long time, agencies for a long time resisted additional data. Because once you have the data, now you own it, right? And then you also own the responsibility of what are you going to do about it? Because that's what communities are going to say. But now, having crossed that threshold, you're going to see more and more data come to bear. So we're definitely going to be, as you can see, relying more and more on that. I think what is really important to make a point about, though, is not all data is created equal. And, you know, I get this question a lot. Why do we have so few regulatory networks? Well, because they have a very specific use. It's for regional air quality, compliance with the NAAQS, and you don't need a network on a station on every corner, right? So I think we do need to think about and talk about that not all are created equal. Purple Air, for example, it's a great, but it's a screening tool. It's just, you know, up or down. Do I go outside or not? I was going to ask Jessie, you know, if Kevin mentioned your satellite data, you might want to also look at Purple Air because, again, it's got some biases that we understand. So I think it's a great question. I think, and this kind of convening is I think, the right setting to ask ourselves precisely that question. You know, what is the future of all this data? And what is the right way to use it for the different purposes, including policy and decision-making? Anybody else?
Thank you. That's an interesting perspective. As a meteorologist, it's really interesting to see that fine detailed data and include that in forecasting. And our perspective has been the more monitors there are, the more you can kind of parse out what is believable and what's not. So I think from that vantage point, it would be awesome to have more Purple Air sensors. However, the more access that the public has to the data, the more, when there's bad data, there's a lot of questions that get raised from that. Not that that's a bad thing, because it's our job to make sure that the air gets cleaned up, but it gets a little complicated with the messaging. And I think explaining that to folks is important. It's not just like a temperature sensor where you can understand if the sun's shining on it, it's going to be a little bit warmer. I think people are a little more skittish about air quality. They're like, what am I breathing in? What is this? But I do think having more Purple Air sensors would be interesting from a forecasting perspective for sure.
I just want to make a really quick point in the interest of full disclosure again, because how many times have we made reference to Purple Air, right? Just for the record, on the market today, there's probably more than 50 technologies. So let's just keep that in mind, right? That kudos to Purple Air because they clearly have gotten all of our attention and the public interest. But again, I think it does behoove us to ask ourselves, you know, are you just interested in Purple Air or is it a specific principle of measurement that would help you with your comparison? So just putting that out there.
Leaf pulse and warming DEQ. I'm in the ambient air monitoring world, and I think just on a note, all of those ambient air monitors, whether they're federal reference method like filter-based particulate or federal equivalent method continuous particulate, they have a specific scale that they are measuring that's defined by the EPA in the CFR. It could be very narrow, like a fence line type scale, micro scale, I believe, or a neighborhood within a few kilometers, or a broader urban scale for several kilometers. So it just to make a point that while coverage ideally would be better to have everywhere, certainly, they do have a definitive scale depending on their purpose and why air regulatory agencies put them there. So.
Yeah, I mean, just to add to that, that seems to be an issue with the Purple Air or low-cost sensors. That network is organic, definitely by nobody's design. It could be right next to a barbecue, and you see skyrocketing readings and causes of concerns. And then also, our analysis found that even though I think Purple Air network now outnumbers EPA monitors 10 to 1, there's a lot of dead weight in the system. It doesn't actually generate 10 times the amount of useful information. So I think there's a lot of tender loving care that has to go into making use of the Purple Air reading.
Tender loving care, sorry, is that all right? I like that, tender loving care. That's a good way to put it. Could be scientific analysis, but tender loving care translates much better. So about the Purple Air sensors, I think probably the way the reason they caught our attention, they were probably out first. They had great salespeople, but also the EPA looked at them and they had a calibration routine. And so they not only have a calibration routine, but if you're looking at it and you're taking tender loving care, you take a lot of monitors from the same locality before you actually believe it. And that they were incorporated into air now. That was almost kind of a coup because the EPA has been very specific about data that it would accept. And so this is taking kind of a lower level of data. And the reason that they allow it is because it gets information out fast. It's air now, it's not used for regulatory purposes. So they have accepted it. So that would be another part of that. And I guess the other thing that I wanted to mention, and I think I'm missing a point here, is the small fires. There's definitely a point beyond which that we don't see small fires with satellite data that we have now. We actually, with Jeff Pierce, our team has been looking at this, and we'll talk about that later, both the social aspect and also the satellite aspect this afternoon. So more fire stuff. And I think that's it. Thank you. Did that help? Or actually, the other thing is you're looking at exceptional events. Those have to be quantifiable too with the same data.
So I just wanted to share a response from online. So Dan Welsh says, in response to Dr. Pierce's question, and this was your question about early morning satellite smoke pooling. So in Colorado, we absolutely do use early morning satellite imagery to help guide us to the areas where the most intense smoke impacts are located. However, this is still a qualitative assessment and must be supplemented with ground monitor observations to fully assess the severity of those impacts.
Thanks, Dan.
Okay, so I guess I got to ask the last question. Actually, it's a follow-up to Amber and Jeff's, especially Jeff's presentation. That is the receiver of all the products and the information. We've talked about other government agencies, research institutions, academics, for example. But I feel like there's another group of users of that information, which is the communities. Right? Some of the projects actually have community stakeholders and partners. So I'm wondering, and this is for all the speakers, I'm wondering if the outcomes, the products that you have produced actually received any feedbacks from the stakeholder. And if so, how do you factor their response reactions into the improvement of your product? Anyone care to?
But Amber, you may have thoughts here too. So for the prescribed fire tiger team, where we have had citizens host monitors, and they were a lot of them were citizens that were interested in the question already of how does smoke from prescribed fires impact where they live. They through our training for how to set them up and whatnot, we got some feedback on what worked and didn't work, and then we would send updates during the campaign with some information on what we were seeing. And then for Kansas, we've had a Zoom meeting for those who wanted to attend with moderately analyzed results. And for Florida, we're not at that point yet. But we have not, other than the trainings, I don't think we've cycled the information feedback from them.
Did their feedback actually change your research directions or inspire new research?
Not that I can think of at the moment, but in terms of anything significant.
Yes. Okay.
As a health researcher and someone who's done a lot of work with risk communication, if I could make a suggestion, when you look at the magnitude of concentrations we're talking about and its temporal patterning, I think the group that would most benefit from these tools by far are occupational workers, outdoor workers. The levels are not high enough that it's going to change anything on the AQI scale that the public's hearing. It's going to go from moderate to moderate or good to moderate. But occupational workers are outside all day long. These changes in concentrations from the even small fires is relevant to their health. And they're the type of people that could benefit by far the most from having daily information, letting them know, do I need to take protection? Do I need to stay inside? Do I need to shift my crew, let them know what's going on? So I think that's a target-rich population we should be thinking of for the next round.
Jeff, did you want to add instead?
No, I was hoping you would.
Okay, but not much. So just thinking about the Flint Hills and focus on that. The people that were burning, and you, I believe Bonnie's going to talk about this later, in the Flint Hills, they burn because they have to, or it would be much worse. So those people weren't, their opinions didn't change really. They knew what, I mean, they were willing to take part and they knew what was happening. And if anything, both sides learned from that experience. So everybody learned from that experience. City dwellers, urban dwellers, it was a different story, what their opinion was about burning. And I don't know if we actually interviewed any of them to know how their opinions changed. I don't remember, but perhaps Jeff would add to that. The story in Florida is a different type of burning, and the outcome of that will likely be different.
Sorry.
All right, it's 31. Well, thank you all for having this great session, great discussions, and let's take a break.